Today is April 22nd, 2019. This is the first in a multi-part video series showing how to create methods in OmniView for producing results from spectra produced by the Nero analyzer. In this video, I will show how to add a method that uses scan data to produce a simple result answer without using any third-party software. The method I'm going to create will find the absorbances at two peaks in this spectrum and take the difference between them. To get started, open the analyzer screen. Before we can make any changes, we need to lock the analyzer. Now select the channel where you want to add a method and click the Methods tab. I want this method to be on channel 8. Click the Add button and assign a name for the new method. So the Add button is this purple plus sign. Click that. And now I'm going to give my new method a name. This name can be anything and can include spaces as well. The next thing to do is assign a script for this method to execute. If a script already exists that you want to use, simply select it here. For this method, we are going to create a new script. So I will select Create New Script, and I'm going to give it a name. You can use the same name or you can give it a different name. That is totally up to you. That tells me that the script has been created. Right now it's just an empty script. I'm going to edit it. Before it can go on, OmniView wants me to go ahead and save the change in the script name, so I'm going to do that. OmniView opens an external editor for you to enter the script. Just a note, if this is the first time that you have edited a script in OmniView, it's first going to prompt you for the name of the external editor that you want to use. Microsoft Notepad is the default, so I use another editor that I like a little better. The script needs to be written in the Python scripting language, version 2.7 or earlier. If you're familiar with Python, you know that you must import the code modules containing the functions you intend to use in your script. So if you want to call a function that lives in another file, you have to import it first. We do provide a library of functions for you to use. This library, these functions, live in this directory, in the OmniView scriptlib directory on the OmniView server host. We encourage you to view the Python files there, but we warn you not to modify them. We don't want people in there making changes and possibly introducing bugs into them. If you want to add your own library file, you can do that. You can add a new file to this directory, but please don't edit the files that already exist there. So now, in this external editor, I'm going to write the script that we want this method to execute. So the first thing we want to do in this script is get the absorbance spectrum. I'm going to assign those absorbances to a variable called AUs. So the getAbsorbances function will return you an array of absorbance values. I tell it what scan I want to get absorbances from by providing the variable scan. Scan is a special variable that we put the value of the latest scan on this channel. So you pass that ID to this function and it returns an array of absorbances. GetAbsorbances is a function that lives in the library, and it exists in a file called gwiscan.py. Normally you would have to import that file by providing this statement here. Notice you don't put py on the end of it. You leave that off. Now, Because so many of the most commonly used functions are in this module, GWI scan, we import that for you. So we don't require you to do the import of GWI scan. So I don't need that line here. So now we have the absorbances. We also need the wavelengths where those absorbances were found. You get the absorbances from that scan by using this function. And again, you have to provide the scan ID. Now that we have the wavelengths and absorbances, I'm going to be calling a function which needs the derivative of the absorbance spectrum. So we're going to compute the derivative of the absorbance spectrum by using a smoothing and derivative calculating function. Some of you may be familiar with the Savitsky-Golay method, so I'm going to use that method here. I'm going to assign these to a variable. Okay, so this is another function from our library, and we pass it the absorbances we had gotten before. The next parameter to this function is the window width to use in the smoothing process and derivative calculating process. The next value is the order of the Savitsky-Golay function that we want to use, the cubic function. And finally, we're not just smoothing, we also want to calculate the derivative. So you specify that by saying deriv equals 1. Okay, so that's how you calculate the first derivative of the absorbance spectrum. Now notice that this function lives in the GWI filters module. It's in a file actually called gwifilters.py. We do not import that one for you like we do the GWI scan module, so we need to import it here. Actually, it just needs to be imported before we make the function call, but I like to put all my imports at the top. So now we have first derivatives of absorbances. We're going to call another function which uses those derivatives to find peaks in the spectrum. As some of you will know from your math classes back in high school, a maximum or minimum, those occur where the derivative crosses 0. So that's what the function I'm about to call here, that's why it uses derivatives. So I'm going to assign a variable here. I'm going to look for a peak near 1144. I don't know exactly where it is, so that's what this function is going to do, is find that peak exactly for me. All right, that's the name of the function. I need to give it the wavelength array. I need to give it the derivatives array, and I need to give it a starting location. I want it to look near 1144 nanometers for that peak. I'm going to do the same thing for the peak that I know exists near 1680. Now, what if I want to, for debugging purpose, what if I want to see what values that this function is giving me for the location of those peaks? Well, you can put print statements into your code. All right, the function find nearby peak can return a null result, which in Python is known as none. If it is unable to find a peak there, it will return none to you. So I don't want to use those numbers unless they are actual numbers. So you can test them like this. if 1144 is not none, and this variable is not none, then what I'm doing here is I'm using that exact location of the peak, and I'm going to call a function here which gives me the absorbance in the spectrum at that location. Get absorbance at. Now again, I have to provide the scan ID and the exact location where I want the absorbance. If either one of the peak locations is not a number, is a none value, we want to assign an answer of 0. I want my answer to be, in the case that I did find the peaks, I want the answer to be the difference in the absorbances at those two peaks. So I saved the file, the script, in my editor, and now I'm going to close the editor. Now OmniView prompts me if I really want to keep those changes that I've made to that script. And I say yes. But I have a syntax error. Some of you may have noticed the error that I intentionally put into my script. The error is saying unindent does not match any outer indentation level. Okay, so that's telling me there's something wrong about the indentation. It's telling me the line number 16. So would I like to re-edit the script now? I say yes. It opens the editor back up. I go to line 16. That's this line here. Note that Python uses the amount of indentation at the beginning of a line to determine the scope that that line belongs to. So basically it's telling me I indented 4 spaces here and only 3 here. That is an error in Python syntax. The indentation at the beginning of the line is extremely important. So I'm going to move that line over 1. Notice this is an if statement. If statements always end with a colon. What follows the if statement, if it's indented, and they're all indented the same, those all belong to this part of the if statement. Notice that I need that to be scooted over 1 more as well. If statements can have an else statement, which also ends with a colon. So the indentation indicates that this line belongs to this part of the else. All right, so I think I've fixed my syntax errors. I again save the file, quit out of my editor. OmniView asks me again, do you want to save these changes? I say yes. Okay, that time there were no syntax errors, and it saved the script. Method scripts can be viewed from this screen right here. Method scripts. It brings up this window, and it shows you all of the scripts that have been defined in OmniView. We have quite a few because this is my development machine. I've done a lot of experimentation with scripts. Let's go look at that script just very quickly. These should be in alphabetical order. There's the name of the script. If I click it, it shows me the script that I've entered. Note that you cannot edit on this screen. You could click this button to bring up the editor again to make changes to that script. I'm satisfied with the way it is, so I'm just going to close that window. Now, after having done that, giving the method a name and assigning a script to it, I should have a fully functional OmniView method for producing an answer given a spectrum. One thing I did forget to mention, let's go back and edit the script again. Remember, the variable scan is a specially named variable which OmniView provides the value of the latest scan. Another special variable name is answer. Your method must produce or set a variable named answer. If you do not, your script won't do anything. Behind the scenes, OmniView, after the script executes, looks for a variable in your script named answer, all lowercase, and when it finds it, it takes the value of that variable and stores it in the database as the result of the method. The indentation at the beginning of the line is extremely important. The spacing, or the white space within a line, is not. So this line could look like this, or I could take out the white space altogether. It doesn't matter. White space is ignored after the initial white space at the beginning of a line. Now the next step would be to see if this script works. And we have a button down here for test running the script. The way it works is when this button is pressed, OmniView goes and finds the latest scan on the channel. If I were to click this, it would go looking on channel 8 for the latest scan. In a new OmniView environment, you may not have any scans on a particular channel. So I'm going to show you how to provide a scan, how to run a scan so that you can test run your method. To do that, go to the scan screen. The screen is showing the latest scan produced by the analyzer. But there's a button down here to demand a scan. If it's not on channel 8, select it, or select whatever channel you're working on, and then click Run Scan. Now in the background you probably hear my analyzer coming to life and running the scan. It's currently using whatever channel settings have been set for this channel. There. It just produced a scan. This channel has been set up to scan the validation filter that we have in the filter wheel inside the analyzer. And what the method that I just wrote is doing is it's finding the absorbance here at 1144 and here near 1680. And it's simply taking the absorbance value, taking the difference between this peak and that peak. Now I'm guaranteed that I have a scan on channel 8 so that I can click the test run button. That ran the script that we have just written and shows me what answer has been set to. It's also asking me, would I like to examine the method's output? And in this case I do, because I put a couple of print statements in there. And you can see what those produced here. So that peak at 1144 is actually found at in this particular spectrum at 1144.18, and the 1680 was actually found at 1679.62. This simply demonstrates that you can put print statements into your script and see the output in this window here. This will be important when you're writing your own scripts for debugging purposes. So now, say I'm satisfied with this script and I want it to produce answers on a regular basis. In other words, every time that the analyzer produces a scan on channel 8, it's going to run models in this list that are online. Currently, this model is offline. So to turn it online, you simply click here and confirm that you want to turn it online. Now that this method is online, it will produce an answer. So let's go do another demand scan on channel 8. Note that when you test run, it will not produce an answer in the answer repository. It's only when a scan is actually run and the method is online will it produce an answer. Okay, so it produced another scan, looks remarkably like the previous one. Let's go to the answers screen and go to channel 8, select our method. Now there's only a couple of values here, so I'm going to go to table view. Actually, there's only one value. We've only produced one scan with the method online, and we can see the value produced. So if I had a schedule that was regularly running channel 8, you would see answers be added to this table on a regular basis. All right, one final thing. Say we wanted to run the same method on channel 9. We provide a way for you to copy and paste this method from this channel onto channel 9. so that you don't have to rewrite that script every time, or you don't have to go through the process of adding a method, giving it a name, selecting the script. We can do that more quickly with these two buttons right here, copy and paste. So with this method selected, note that it's in purple. If I unselect it by clicking Control click, it's not selected. So I select it and click there, copy. Note this button comes alive because we have a method copied now. If I go to channel 9, paste. This concludes the first part of this video series showing how to create and use OmniView methods.